We will start our class on time. 6:30. Jacks. Hello. Well, we'll start our class today. Today, I'm gonna give you a new chapter that is about parallel computing. That's concurrency. It means the parallel computing. Yeah, to do two or more tasks at once. This is topic of this chapter. Actually, we'll talk about parallel computing in this chapter. The parallel computing is really popular in these days. So, in this chapter, we will learn how to do this parallel computing using Java programming language. Okay. Yeah. At the very beginning, let's look at this definition for the thread. As we know, in computer, we have a concept named as process. A process is a program, but that the program is running. When the program is running, we call it as process. Yeah, this is concept. We have a process in a computer. It means a program that is running. If a program is not running, we do not call it process. At this time, this program is on our disk. It's a file. But when we run the file, we launch the file, and this file will be loaded into memory, and our CPU will execute the code inside the program. That at this time, this program, we call it as process. And what is a thread? Based on this idea of process, a thread is single sequential flow of control within a program. Yes, within a process. So we cut the process into different parts, different sequential flow of control. That is thread. So a thread, this idea is inside a process. We divide the process, divide the flow control inside the process into different parts, into several parts. Each part we call it as thread. This is concept for the thread. So inside the program, inside the process, if we have only a thread, we name it single thread program. Actually, we often make more than one thread, for example, 2 threads or 3 threads inside one process, so it's become multiple threads inside a process. For example, here, inside a process, we have 2 threads, 2 sequential flow of control. So this process have 2 threads inside it. For example, now if we want to make a music player that running based on the internet, a music player, so the music data is not coming from our disk, it's coming from the internet. Here is a music player. This is a music player. For example, name it music player. Music player. It's an online music player. So its data come from the internet. So data come from internet. We use one thread. This thread we name it downloading. Downloading thread. This thread, we use this thread to download the music data from the internet. This task is for downloading data from internet. Another thread, this thread, its task is to decode the data. So it's decoding and play. It's decoding the data so you can play the music through the speaker. So there's another thread. So we have 2 threads into this online music player. Online music player is a program. It's a process, and inside this process, we have 2 threads. One for downloading data from the internet, another thread is for decoding the data and playing the music. So these 2 threads work together, work concurrently, and this So where we downloading data from internet, and we can play the data at the same time. So it continuously with music, we do not have break. We will have continuously, we can enjoy the music continuously because the two threads working together. That is thread. So we're using thread with this concept to do the program. So that's this idea for the threads. And next, we will talk about how to create threads in our program. We have three methods to implement to create a thread. We will learn the first one, the second one. The third one, we seldom use it, so we just omit it. So the first one, we use the subclassing. So we have the thread as our superclass, and we subclass it, we have get a new thread. This is first method. Another way to get a thread is implement a run-up interface. So the second method is implement a run-up interface. So we have two ways to creating thread. The first way is we have a superclass as thread, and then we will make a subclass. The subclass is new thread. Is the first way. The second way is we have interface as an API of the Java platform. The name is runnable, and we implement this interface. We got a thread object. There's another way to implement a thread. So I have two ways to create a thread, and I'll give you some examples for it. Now look at the first example. We will subclassing the thread and get a new thread. So our task is now we want to create two threads. In the program, we will create two threads, and their task is same. The task is the same. The task is the two threads as tasks are the same. That is, they will print out strings. Print out strings on a screen. That is, now we have two threads, and here it's our screen with display area with text display area text screen, and we have two threads. This first thread, the second thread. So we build two threads and work together. They have the same task, that is print out string to the screen. So the first, for example, we use two different colors. This we use green. This green color stands for the first thread, and red color stands for the second thread. And we'll print out strings. value for this program that it's sleep time limit different. So we will see the different results once we execute this program. Okay? So that is the task we want to do for the program. So we have two threads working together, print out the string to the screen. How to create this thread? The first method, the first way is to subclassing the thread. So now we print out index and the name of that, and then we sleep for a while for random interval 1 second. The sleep method, the argument inside it will use this 1000 millisecond. So it's 1 second. So sleep for 1 second or less 1 second. to make it run. So that is, we have two threads. One is Jamaica, another is Fiji, and work together. They print out string to the screen at the same time, simultaneously. At the same time, print out string to the screen. That is our program. You can run the program inside NetBeans. In NetBeans, is to implement a runnable interface. So we will write the program. At this time, we do not subpassing thread. Instead, we implement the runnable interface. So we implement runnable interface. It is the same. Run method. Inside it is a task that this thread is required to do. Remember thread to implement the runnable interface, so we should put it to the new keyword, new theme thread. This is first argument. The second argument is a name of thread. So the name of thread, one is Jamaica, another is Fiji, the same. Once we get this thread, we must make it wrong. The start method make it wrong. So the same. That is just the second way to create a thread, and we will inside NetBeans, if we use this thread, use this interface implementation, we will get another code for it. That is, we implement the run interface, we define run method, we write the run method, and we create two threads for it. Notice the difference to create the object for the threads. A little difference. Now we got two threads working together. They're the same. The result the same. Two threads, Jamaica and Fiji, the plain old string on the screen. So that is our code for create threads in our program. Now we know have two ways. One is subclassing the thread. This is the first way. And the second way is implement the runnable interface. So we have two ways to create threads. Which one is the best way to create thread? The answer is the second one. Implement the runnable interface. Because as we know, if we subclassing the thread for getting a thread, that means this class we cannot subclassing other class. Because in Java, a class only have one father, only have one superclass. So we have a superclass, we become a subclass of superclass, and a superclass is thread, so we cannot become the sum of another superclass. It's a way that we use often in our coding. Now we will give you another example for demonstrating this creating thread inside of a program. Okay, back to thread. Now, this example, we will design a digital clock. I will design clock. So as we know, what does a clock mean? The clock means that we have time, but the time is running. It's not a static. It's running. It's a running time. That it's a digital clock. We run the code for it. Clock. This clock. And look what our digital clock looks like. Run the file, and we will see our clock. Now it's our clock. It's a running clock, so we have time, but the time has changed. Each second, it changes the number for it. The second, the minutes, the hour. That is a digital clock. How to create this clock? I want to create a clock. So it's a clock program. We have two threads to do it. The two threads to do this job. We'll come back. How to do it? Now, inside the program, this clock, we have two threads. Got another corner. Purple one at the thread. So this thread we name it clock thread. The clock thread, what it's doing for this digital clock, its task is to get the signal, get a refresh. Because as we know, as a clock, how we design a clock, we come back to code. This clock, how we design it, we have API inside Java platform. We have the API that is calendar. We have calendar. That's calendar. That calendar, we use this API calendars to get the current time of the system. For example, current time is now it's 19. For example, 19 is hour, and 1 is minute, and second is 38. This is current time. And if we use the API as a minute later, so the calendar data is 19 is hour, minute is 1, and second is the previous is 48, the next is 49. So if we get the calendar data, use this clock thread. The clock thread, we use clock thread to get to this calendar data every second. Every second we got the data. Every second we get the data and display on the clock. So we get a digital clock. So we should have a thread named as clock. This clock thread will get the data every second. This is task. But we should have another thread. Another thread is for display the time of our application interface. This application have a graphical user interface, so we have to display this time on an interface. So we have another thread. This thread, we name it AWT thread. It's another thread with a different color, for example, green. The green color. The clock, our program, is a a program with a graphic user interface, so it must subclassing the JFrame. So the clock has already the subclass of the superclass JFrame, so it cannot subclassing another class. So the only way to implement a thread is to implement the runoff interface. So we implement runoff interface. This is stands for the clock application because we use this application to implement the runoff interface. So the clock is this clock, and clock is a thread name clock. And once we got this object, we'll make it run. So the start method to make it start clock thread start. Okay, and come back again. So 1 second interval, 1 second interval, 1 second interval. Each time it will refresh, repent. And the repent method will, the AW thread will do the job. The repent will make an AW thread to refresh the interface. And how to do it? We use the pen method. So once we, in the clock thread, we have a repent method. And once we invoke repent method, and AW thread will execute the pen method. So the AW thread execute the pen method when we make the repent operation. The repent operation is made by the clock thread. Every second, it repent once. And when it repent, the AW thread will invoke the pen method. So the pen method, it will execute every second. Repent every second, pen, every second, pen. Inside the pen is to get the calendar data. So we create a calendar object, use calendar get instance. The calendar is a special object. We do not use new method to get this object. Instead, we get instance in this method to get the object for the calendar object. And then we get the date information and the time information from this calendar object. But at the digital clock, we only use hours, minutes, second. So that is hours, minutes, second with the get method, and we put it into the int value, and we now we combine them to a string, and then we use the graphic object. MG is a graphic object to display something. Display this string. This string is the format is hours, minutes, and seconds. That is digital clock. So a draw string will display the time information, the data, on the screen of our clock interface. So we got a digital clock. Every second, the clock thread will evoke the repend method, and then the AW thread will invoke the pend method, and inside the pend method we will get the current time and display on the interface of our application. So we got this running digital clock. That is the running digital clock. This is how to work. Well, two threads into one code, one program, clock thread, repend every second, AW thread, pen it and get the time and pen it and draw it on the screen every second. So we got digital clock, a running clock. That is clock is analog clock. Now, instead of digital digits of the clock, we use the hand, the hours, the minutes, and seconds of hand to display the current time. So, but we have a third method. Inside the code, we have two threads. One is clock thread to make this repend operation. Another thread, an AWT, will pend the time. Instead of digits, he will draw the hands for the minutes, the seconds, the hours, draw the hands for it. We have fourth experiment. The fourth experiment is to create a clock. So maybe you can design an analog clock based on this code. Yeah. That's a clock application with two threads. The clock thread is defined by ourselves, and it's make this refresh, make the repend operation every second. Okay, let's for it. This. And then now the next section, the life cycle of a thread. As we know, the thread is object. An object, we have three basic status, but thread is special object, so it have 5 states. The 5 states is new thread, runnable, running, not runnable, and dead. The 5 states, and each state we get in from one state, we get into another state. If we invoke the method, we will jump from one thread to another one. For example, now we will create a thread, and once we got a thread and make it start, it will become the run state. And the run state can become running state, and will become a lot of run states. Eventually, they become dead states. The 5 different states. Okay. Just have a break for 5 minutes. Mason Law 4. Still number one is 110.
110.
Yeah, 110. And then 112. Okay. Thank you. Yes. And that one is 122. 122. 122. Not here. And 125. 125.
Oh, yeah.
5. And next one is 127. 127? Yeah. Okay, thank you. And next one is 128. 128. Okay. From 3. What? What's your number? Which one? 28. Oh, 28.
Yeah.
28. What? We come back to our class. And about the life cycle of the thread, we have 5 states. New thread, runnable running, not runnable dead. And we invoke a different method. Well, we change the state from one state to another state. We give example for it. Use the clock application. I gave you previous example clock thread. For example, we use the new thread, use method. We got a method at this time. This thread, the state is new thread. So we use new method. We got this thread and its new thread state. And then we use a start method for this object, clock thread. Start method. Once we use start method, it will change the state from new thread state to the runnable state. Notice it's a runnable state. So we use the start method will make this thread change state from new thread state to runnable state. Runnable state is not running. Runnable is not running. The runnable is ready to run, but it's not running. Ready to run, well, it gets the time, get execute time from the CPU, from the processor, it will running. Because the CPU execute the statements inside the run method. Only CPU on the processor can execute the statement inside the run method. So the runnable is not running. Once the JVM, it will, for example, JVM will give this thread the executing time. It will become running. The CPU, the processor, will execute the statement inside the run method. So the run state is ready to run. Once a thread which state is runnable, it got to CPU time from the JVM. Then it will become running state. Once it becomes running state, the statement we write in the run method will be executed. So that is the difference between the runnable and the running state. And When this thread is running, it can become not runnable state. That is, we have three different events. If the three different events occurs, that it can become not runnable. The first event is sleep. If we invoke the sleep method, then this thread it will become not runnable. If the inside of clock thread, we have the thread sleep 1000, that is 1 second. So it sleep 1 second, then the clock thread will change its state from running state to the not runnable state. Once 1 second, the time's up, it comes back to the runnable state, not running state. Remember, it's come back to the runnable state. From the not runnable, it comes back to the running state. And if he wants to become running, he must get the executing time from this processor. Then it can become a running state. So that is the not runnable state. And the second event that it's if the thread call wait method and it become not runnable. If it's do some input and output operation, it will block and become not runnable. Once the sleep, when the time is up, it come back. It's from the not runnable state to the runnable state. And the wait method, if other threads notify it, it will become the runnable state. And if a thread is waiting for the input-output operation, once the operation finishes, it comes back to the runnable state. That is the state change. And then the final state is a dead thread. When the thread becomes dead, as we know in a side-run method, if inside the run method we only have limited statement. Once all these statements finish up, and then the thread will go to end, will go to dead state. For example, now have a run method. Inside the run method we have a loop, but the loop is affinity loop, 100 times loop. Once this loop finishes, all this code, all these statements inside run method have executed, have finished up, and then this thread goes to the end, come to the dead state. But if a run method inside run method we have not an infinity loop, not infinity loop, have infinity loop, so the thread will keep running, never go to end. At this time, how we end it. So if we want to end a thread, force it to go to end, we make it as null. For example, a clock thread. A clock thread, inside clock thread we have infinite while loop. It's an infinite while loop. This condition always true. So it's infinite while loop, and this clock thread will keep running, never go to end. But if we want to make it end, we have to make it the reference variable as null, assign a null to it. So this clock thread will stop and go to end. It's come to dead state. It is how to change the state between the different states, how to change them. We use different method, invoke a different method, will change the states, change the thread states. There is a life cycle of a thread. Right? And then the next section we will give you is it's about the resource sharing. As we know, the threads inside the program we have, if we have more than one thread, for example 2 threads or 3 or more threads, they will share the same resource. I have an example that this music player, the music player will have a downloading thread, the download data from internet, another thread decoding it. So these threads share a common buffer. A buffer is the storage. For example, it's an array, a byte array inside of a program that share the same resource. So the different threads into one program will share the same resource. Sometimes it will become error, become the sharing. In some situation, it may be become a deadlock. Will become a deadlock between the threads. The deadlock is ultimate form of starvation. That starvation means if we have 100 threads into one program, but one of these threads never get resource, never get to CPU executing time, it never execute, or it never get to resource to make some operation, it becomes starvation. And the ultimate form of starvation is deadlock. That is, all these threads are waiting for the condition, but this condition never to be satisfied. I will give example. What is the deadlock? That example is dining philosophers. This is a classic example for the deadlock. The example is now we have a round table. And we have 5 philosophers. 1, 2, 3, 4, 5. 5 philosophers. They sit at the table, the round table, and they will share resource. Which resource? Chopsticks. So we have chopstick. But we do not have so many chopsticks for each of the philosophers. So we only have 5 chopsticks. This chopstick, as we know, if we want to use the chopsticks to eat rice, we have to have a pair of chopsticks. Only one chopstick, we cannot use it to eat rice. So we should have 2 chopsticks and use it to eat rice. So, for example, this philosopher, it wants to eat its rice here. He must have 2 chopsticks, then he will eat his rice. And it's the same. Each philosopher have a bowl of rice, rice. Okay. But they share the chopsticks. So we make a rule for the rule for each philosopher is the same. The first step, for example, this philosopher. The first step, pick up the chopstick on its right side. You get the chopsticks on its right side. The first step. The second step, if you got its chopstick on its right side, then you can get into the next step. The next step, you get the chopstick on its left side. If you get its left side chopstick successfully, now you got a pair of chopstick. Then you take a bit of rice. You take a rice, but the rule make each philosopher cannot eat continuously. Eat a bit of rice and then must put down all these chopsticks. Put down the 2 chopsticks. So they put down the left chopsticks and the right chopsticks for the other philosophers, because the other philosophers is hungry. They all want to eat rice, so we must put down the chopsticks and let the neighbor have the opportunity to eat rice. So he paused for a random period of time, and then he come back and try to get the chopsticks on its right side and on its left side. Once you get the parallel side, he eat rice and put down the chopsticks and have a break for a random period of time, and then he come back and get the right chopsticks and left chopsticks, and then. That is the dining philosophy example. So at this time, we may think each philosophy is a thread. So we have 5 threads. The 5 thread is sharing 5 chopsticks. This is the common resource. And let's look at what will happen. The first step will pick up the chopsticks on the right side. For each of the last 5, they try to get the chopsticks on his right side. There has one opportunity. Maybe at this time, all these philosophers get the chopsticks on his right side. There's a moment. At this moment, all these philosophers grasp the chopsticks on his right side. Then they want to get the next step, pick up the chopstick on his left side, but no chopsticks on the left side, because all the chopsticks now is on the hand of the philosophers. Because at the same time, the first step, same time, all these philosophers get the chopsticks on his right side. So the next step, the second step, no chopsticks on the table.
If you are using a clock and then chopstick in the computer that the normal clock
No, I don't think.
is different from the normal clock.
It's different from the clock. Yeah.
Why?
Because I think it's different. It's a different problem. Now, this resource is limited. We have only 5 resources. Limited resource. If we have enough chopsticks for all these philosophers, we have 5 parallel chopsticks. This dining philosophy problem, these problems, no problem. Each philosophers have these chopsticks, each rice, no problem. No matter where they have a break or not, because they all have a pile of chopsticks, they all have enough resource. But in this problem, they only have 5 chopsticks, and the 5 philosophers share the 5 chopsticks, so they may have a problem. Follow these steps. All these philosophers must obey the same rule. No one is allowed to break the rule. Get the chopsticks on the right side, then you can try to get the chopstick on your left side. If you cannot get the chopstick on the right side, you cannot get the next one step. So, but at one moment, all these philosophers pick up these chopsticks on the right side, so no chopsticks on the table at this time. So, no philosophers can get into the second step. That is the problem. So at this time, We call all these threads, the 5 plus 5 threads get that knot. It's stuck on it, always, never come to the next step, to stuck at this step. We will show you example, the code. For this code, we can make a program for the dining philosophies. Now you can see what is done not happening. Yes. Dining philosophies. It's applet, so execute this dining. That's well, not this kind of file. PHI. Oh, yeah, Miss L. Now so we have 5 Duke. The Java Duke stands for 5 philosophies, and they have 2 hands. When he writes the left hand, means he got the chopsticks on the right side. Left side, the right hand means he got this razor hand, means he got the chopstick on his hands. So I have a variable that is interval, is sleep, the break for the interval. For example, we sleep for 5 minutes, 5 seconds, and 5,000 milliseconds. That is 5 seconds. We start. See, when we got 2 sticks, have a rice, and then they pull down all these sticks or chopsticks, and have a break for random interval, and so the neighbor philosopher can get these chopsticks, and once they get 2 chopsticks, have a rice, and then put down all the chopsticks, and net these neighbors have opportunity to get these chopsticks. So it's kind of no problem, but when we change the interval and make this break for a short time, and we see it will become the reason that they have this rise become faster and then faster and faster and faster. We wait this moment. At one moment, you see that all these philosophers get the chopsticks on his right side. Then no chopsticks left on the table, so they cannot get to the next step. That means no one can get the chopsticks on his left side. So the program stuck here. That is that knot. If you have a program, because nowadays the parallel computing use threads. It's really common for today's application. Today's application, we have a server. For example, we have different kinds of application. At the client, it's app on the phone. For example, we have the app to get to a reservation for a hotel, or we order a takeout food from the app. And the back end is a server. The server will provide service for all these apps, all these clients. Because we have so many clients, one server may provide service for 1,000 or 2,000 or even more clients. So inside this server, we have threads. One thread provides the service to one client. So 1,000 clients, we have 1,000 threads in our server. On the internet, we have a server. Inside it, we have 1,000 threads in it. and each one provides service for one client. But if at the moment all these threads go to the deadlock state, the whole program stops here. That means all this service will stop. And this, for example, you allow your order something that you cannot get into the next step because all this service go to the deadlock state. So deadlock is a disaster for replication, for the parallel computing. It's a disaster, but it's hard to design a program that do not have the opportunity to get deadlock because the basic reason is we do not have enough resource. If we have enough resource for all these threads, for all these philosophies, we have enough chopstick to them, we do not have deadlock. But we do not have so many resources sharing by all these threads. So all these threads are sharing the limited resource that may get into this deadlock. So the only method to deal with this problem is to design a program carefully. Try to avoid this situation, the deadlock situation. That need a practice. And this solution is different from the problems. Different application will have different solutions to do it. So it's a tough problem for a programmer. It's to avoid deadlock. But we can do it to carefully to design the rule, to design a rule that make the rule. It's not. It's for example, this rule is a fair rule for each philosophy. We have opportunity to have rights. But if we make a new rule, but in this rule, maybe we have priority for these philosophies, and maybe it will change the steps, the flow for some of the philosophies, and they avoid the deadlock. Maybe. That's for this chapter, this parallel computing. Now understand how to create a thread in a program. We have two methods to subclassing a thread or implement a runway interface. And the next way is the common way we use it to create a thread in our program. And inside the program, if we implement a runway interface, a very important thing we need to do is to write the code inside the run method, because a thread will execute the statement that I put into run method. So we should write the run method for this code that implements the thread. As example, the clock thread inside the run method is to refresh the interface, repaint the interface every second. And the concurrent example at this threads will print out string to a screen at random intervals. So that is task. Different applications have different tasks for the run method. So that is what we should do if we want to make a parallel computing use thread. Okay. And the rest of the thing is design your code carefully, especially when all the threads are sharing the same resource. So you should make a reasonable rule to make them share this resource, but avoid the deadlock. Okay. That's all for this chapter, and then we will get into the next chapter. The next chapter is for the input and output operation for the Java code. Inside the Java, if we want to do the input and output, we will use a special object named stream. Okay. So we use a stream, this object, to make this input and output operation. The stream, what is a stream? For example, here's the code, our program. Here's our program. If we want to get information from the source, from the information source, we use a stream object. And make read operation. We get information from the source. And if we want to output information to the destination, we use the stream to write information to the destination. So this stream, this object, we can think it as the pipe, the water pipe. We use water pipe. Inside the water pipe, we use water pipe to transfer the water from the water plant, from the water supply to our home. We have the water pipe. So the stream is just like the water pipe. The difference is inside the pipe there's water, but inside the stream is information. That is only difference. So we think about as a pipe. When we start studying this chapter, we think the streams is just like the water pipe. Inside the pipe, we transfer this information. Okay? That is this stream, this concept mean. And in Java, we have different kind of stream, but the operation is the same. We follow these 3 steps. The first step, we will create this pipe. We'll create a stream. And the next step, we will read information or write information use this stream object. And then, once we finish it, we must close the stream object because it's a resource. We should close it, and a resource will be released and to other application. So we should close the stream. So the final step. So we have 3 steps: open a stream, create a stream, and read or write through the stream object. Once we finish it, we should close the stream. We follow the 3 steps. Okay. And in Java, we have different kind of streams, different kind of pipes. One of them is divided by the contents that we inside this stream with different contents. One is character stream, another one is byte streams. If we use this, the character stream is inside the stream. That the information is information inside the character stream. We'll give you draw a picture here. If it's character stream, so it's character stream means inside here is a stream, it's a pipe. Inside is information. The character stream means the item. Each time we read or write, we have what is a character. That means if in Java it's a Unicode, there are 2 bytes. We have 2 bytes for a character. For example, that is 00000000080. It's a byte, and 01000001. That stands for 000010001. That's the 16 bits. 2 bytes means a character A, a big A. Yeah. So inside the stream, the item, the unit, each time we read and write, it's a character. It have 2 bytes. If we want to read or write characters, we should use character string. But sometimes, if we do not care for this character, we only read or write the binary information, not the character. For example, we read a file or write a file that is an image file or a sound clips that do not have characters, so we use byte stream. If we use byte stream, the unit each time we read or write from this stream is a byte. The byte is a byte. So it's not a character. A character has 2 bytes. As a Unicode, we have 2 bytes for a character, but byte stream we do not use character information. All the information is bytes. So depends on different contents inside the stream, we use different type of stream object, character stream or byte stream. Okay. I will give example later. And another category for this stream object inside Java. In Java, we have a package, java.io. This package, inside it, we have lots of pages of different streams object, different paths for streams inside it. So they have different types of streams. Some of them are character stream, some of them are byte stream. Another way to divide them is by the purpose of this stream, that divided as data sync stream and processing stream. Data sync stream, if that purpose is we only get information, get a raw information. If we want to get a raw information through the threads, we don't have any processing for it to use. Then we use the data sync stream. But sometimes we may have some actual processing on this information. At this time, we will use this processing stream. For example, when we read a file, we have a file object. If we read a file object, we only need the raw information from the file. The information from file, maybe it's a byte, maybe it's character. If we use character, it's characters read from it. If it's byte stream, we read bytes from the file. So it's maybe a character, maybe a byte, but all of them are raw information. But inside the file, actually, we have different types of data. For example, now we have int value inside this file. So we want to get the int value from the file, not the bytes, not the characters. We want int value from the file. At this time, we will use this processing stream. That is the purpose, the different purpose. We use different kind of stream. That is another way to divide this whole I/O package. So some of these streams are character streams, some of them byte stream. Depend on our purpose, we'll choose the suitable streams for our program. Okay. I will give an example to show how to pick up them inside this I/O package and use them. For example, now in the Java I/O package, we have a character stream, and the character stream, if we want to read file, the file reader is a character stream, and read information from file. If we want to write information to a file, we use a write file writer is a character stream, and this is character stream. And you want to the buffer function, We want to use a buffer for our reading or writing. So in buffer reader and a buffer writer, it's a character stream. And in the same, we have the byte stream. The byte stream to the file, now we have a file input stream and a file output stream. Each time we read and write the file, the unit, we read, write it bytes. But character, the unit we read or write is the character, that is 2 bytes. Because one character will use 2 bytes Unicode to describe this character. So the unit, the size of unit is 2 bytes if we use character stream, but if you use the byte stream, we only use 1 byte. That is different. And inside it, we will notice that we have the data sync stream and the processing stream. For example, there's file input and file output stream, that is the data sync stream. We only read the file, and using bytes as a unit, we read the file, write file. That is raw information. We do not have actual processing on it. But if we want to read it or write it, use this data type. Use some kind of data type to use int or double or string. Then we will use the processing stream. The processing stream is for this byte stream, the processing stream. That is here we may see the data input stream or data output stream. That is the processing stream. We use this kind of stream to read or write data in some kind of type, int or character or double or float, some kind of primitive type. We use this processing stream. That is the different kind of streams object inside the java.io package. In this chapter, the point is how to choose the suitable stream object, suitable class for our application. That is a point, that is key point for this chapter. So I will give you several examples to demonstrate how to choose the suitable stream object for our application. Let me see. Now, first example is use the file stream, the data sync stream. We don't have actual processing on it. We only read or write file as raw information, bytes or characters. So we will use this streams reader, writer, or the input stream or the output stream. Okay, and now we will make a program. Now the program is to make the copy operation. The copy operation means we have a source file. Now we want to get another file. The file is the same as the source file. We name it the copy operation. So how to do it? Use the Java code. Now we have the source file as here's our file system. We have a source file as a variable. The variable text. Variable text is a source file, and want to get another file. The file is the same as the source file. The variable we name it as out again text. So this is the file we want to get, and now we have the source file and want to get out again a text file as a destination. So how to do this operation, the copy operation? Now we can use this stream. Now we will create a file object, input file and output file for each of these files. Variable text and out again text. We have 2 file objects for them. Variable file is input file, and out again we define it as output file. So now we have 2 file objects. file class, you knew we have two file objects. And now we want to do the copy operation. Copy operation means we'll read a file from the beginning to the end. Here we use this byte string, means we will byte to byte. That means we have the source file from the beginning to the end. Each time we read a byte from the file, and then we'll write the byte to the destination file. The destination is out again, the same position. Each time we read a byte, because we use a byte string, each time we read a byte from the beginning to the end, one by one. Each time read a byte from it and write it to the destination file out again at the same position. We put it here, and then we read the next byte, and then we put it to the next position. So from the beginning until we go to the end, and we have a new file. Out again text is the same file, the duplicate file as the source file variable text. So it makes this copy operation. How to do it? We should use this data sync string, that is file input string and file output string. So based on these two file objects, we create two stream objects. One is file input stream in. From this file, get bytes from this file. Each time we get one byte, so we write a while loop. Each time we get a byte, and we put it into a variable, int variable, put them on the C. And then we'll write this byte to the output stream, and then to this out again text. Then the next byte, and the next byte, till we go to the end. When we read, if the return value is -1, means we go to the end of the file, and the while loop will finish, and then we got same the out again text, the duplicate file as a destination. It's out again text, and remember, once we finish using this string, we must close them. So we use close method to close in and close out. That is for the copy operation. Here we use this data sync string is a byte string. For the same program, we can use this character string instead. If we want to use character string, we only change it to this file input string and file output string to the file reader and the file writer. That's it. We change it to file reader and file writer. And if we change it to a file reader and a file writer, the difference between the two programs is each time we read the file, if we use a byte string, each time we read a byte. But if we use character string, each time we read from file is a character, it's 2 bytes. That is the difference between the two programs. Okay. So there's a break. Have a break for 5 minutes. I will come back to the code. This code is for copy operation to make a new file from the source file against a duplicate file out again, variable. For our copy program, we have a copy program. For example, we have a byte, copy byte program, and we use if you want to use this processing stream that will make this new stream object connect with combined with this file reader or file writer, and the purpose that we use this processing stream is to improve the performance of this program because we use a buffer for them. I will give you example that it's now we have this program, the file reader and file writer. This is the data sync stream. We make this copy operation, and then I will draw a picture for you. And now we have a scene. The scene we have this variable is out again, and we have two object input file and output file, and we create two streams for it. One is file reader in, and one is file writer out. Now it's a character stream. And if we do not use this processing stream or only use this data sync stream, we use the read or we connect the two streams together. We combine them together. Just like we assemble two water pipes, we make them together, become a new functional pipe. So we got the new functional pipe because we connect them together, the buffer reader and this buffer writer. So now we got the new type of this pipe. That's the pipe we have a stream. So this pipe This is new line for this next line symbol. It is new line, be out new line. So each time we read a line of characters and write a line of characters, so we improve the performance of our code. Use this buffer reader and buffer writer. So we use this new type of stream that we get benefit. And write some kind of format with data input and output stream. Here's an example. Now we have, if you want, we have a table inside memory. We have a table, and the table we want to write it into a file, invoice text. For example, it's an invoice text. We want to write a table and create in the memory, and write the table to a file named as invoice text. This is table. The table is that we have 3 columns for the table. The first column, the second, the third. The first column, the data type is double. It's a price. And the second column is the number, the amount, the number of this products. For example, 12 is the number of this product. And the third column is the description for this product. For example, it's Java T-shirt, it's an invoice. We have several rows of this table, and we have 3 columns for this table. And each column we have different kind of data type. Now we want to write this table into this invoice text. If we want to do this, how we should do? Now, as we know, we want to write files, so use the file output stream. File output stream based we pass the file output stream, this object, as argument to the data type, data output stream that connect these 2 streams together. We got a new type of stream. That we use the stream, we can write this data as type, as different type. So we have this new kind of data output stream, DOS. Now we have the DOS, then we will write the data as different kind of type. That's the example. Now we have the table, we define it as the array. The different column, we have 3 columns for the prices, units and descriptions. For the price, units and descriptions, for example, 19.99, 12, and Java T-shirt for the first product, the second product for the Java mark, and second for those, and second fourth for the theme. So when we write this, each time loop, each time inside the loop, each time we write out a line, write out a row. So the first item we write into this file is the price. The price, the type is double type. So use a write double because now we have the data output stream. We have different method to write in different type. Now we want to write double variables. We use write double. Use method to write the price into the file, and then this is for the separator, the price and the number. We use a table. The slash t is a table character, so use the write character slash table, and then we write units. The units is an int value, so it's an int. Now it's a double. So use write int, write units, and then use the write character, and then description. The description is string, so use this write characters is a string. So we write the different kind of information at this type into the destination file, the invoice text. The invoice text. Write it as different type to it. So, and if we want to read this information from this invoice text, and we use the same processing stream, but because now we will read information, so we use this reversed operation that we data file input stream, and we pass it to the data input stream. So we can read the file at this format. It's the same. This is write the table as its data type to the file, and the reversed operation will read the file, so we use the file input stream, and we connect it with the data input stream, and then we use a method provided by the data input stream that is read int, read double, read int. We use different kind of method to read the information, read the data as its type. So we will read the information from the file, and we will create a table inside the memory. So inside the code, and we use the read int, read double to get the price, and read character to skip this table. And next is the next column is the number of the products with int, and we throw out the table again, and then read 9. Read 9 to get the description of this product T-shirt. Okay? And the second is 1, 2, 3 with 3 columns, a different type, so with different kind of method, read character, read 9, read int, read 9 for them. And because this information we got from this method is a primitive type, the read double, we got the price as double, as primitive type double, and read int as a unit is a primitive type of data. So we will use them to make calculation directly without conversion, because they are already the primitive type of data. So we will make this calculation for it. We can get the total price, the technical total price. That's why we should use this processing stream, because it provides a function for us, actual function for us. We use this processing stream. We use this data input or data output stream. Now we can read or write information as its type. So we can make actual processing to the information. That is the reason why we should use this processing stream. That's it's for this chapter, this 9th chapter. What we should learn about is the concept for the processing stream and the data sync stream. And as we know, the data sync stream that is, as example, we give you as the file, as a copy file, we use this data sync stream. And in this example, we don't have actual processing to it. We only read the file as a raw information or by bytes if we use a byte stream, or by character if we use a character stream. We have actual processing. If we want to make actual processing on them, we should use this processing stream. For example, I'll give you an example. If we want to improve the performance of our code, we want to use the data input or data output stream. So we can read or write by some kind of data type. That is actual functional stream that we use. This processing stream is for. The purpose is to use this stream, connect them with this data sync stream, we can get the actual function. That's all the contents that we should know how to get information from keyboard and how to print out information to the text screen. Print out information to the screen, as we know, we in the Hello World, our first Java program, we have the system out println, and system out actually it's a stream, it's an output stream, but the stream is provided by JVM. It's output stream or user stream to print out information. If we print out 9, that we has a line character at the end of the string. Print 9, we use this method to print out a line of strings to the text screen. That is system out, as we know. And if we want to get information, get input characters from the keyboard, we should use the system in. Use this stream. But remember, this stream only works for the command line. If you want to get the characters from the graphic user interface, we do not use system in. We use the components, the text field as we do for the experiments. The text field gets this money we input in this interface. But in the command line, if we want to get information from keyboard, we use system in, use this object. So we use system in. And because system in is the byte stream, but how we do it? Now we will use system in as argument. Will pass into the input stream reader to convert information from bytes to the characters. This is a character stream. We use IR, we use a reference variable, and get this object. And because we want to read, each time we want to read a line, not only a character. We want to read a line of characters, so we want to use a buffer. As we know, we should connect it with the buffer reader again. Connect with the buffer reader, the input reader, the system in. So the system in connect with input reader. We got a new kind of type of stream that can read keyboard information as characters. If we do not use input reader, we only get it as bytes. But we connect with input stream reader, we convert bytes to characters. So we got characters input from stream, but from the keyboard. And then we connect it with the buffer reader. The purpose is we connect with the buffer reader, we assemble them together. Now we can read the character each time, a line, not only a character. If we do not use a buffer reader, each time only we write a while loop read line. Each time with line of input, and we print it out. So we use system out this stream print out method to print out what we got from the keyboard, and it's a while loop. And if we want to break this operation, we can use this force break, that is control break. So we put this statement into a try block and write. Here, 9 code, and now it's a code. This code is get information from keyboard each time a 9 and print it out and run it. And then now input something. Input a 9 of 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, it's a 9, let's return. And the 9 of characters to read, and then print out, and read 1, 2, 3, and then another kind of keys I input and then print out. So it's a simple example, but this example is very important because we have this experiment. In this experiment, let me see the experiment. Okay. Experiment 3. Yeah, experiment 3. In this experiment, this is the third experiment. We will design a text application. We'll read the input string from a console, from command line, and save it as a data file. This is the first code. Another program is read the data file you have created and get the string in this data file and display on the console. So you have to write two code for it. One is for read the keyboard, read get a string, and put it into a data file. And another code is read the data file, get the string, and display on the screen. You can write two codes for this experiment. In this third experiment, we will make it at the next month. We'll do it in the lab. How to do this experiment? Actually, we have the code. We have the copy example, and we have the keyboard input-output example. That we use these statements inside the two experiments, two examples. We will get this code for our experiment. Okay, that is read the keyboard. We use the system in use the string to get keyboard, and we save data file. So we use a file writer. File writer uses string to write the data file. Another code, we read the data file, so we use this file reader. This data sync string file reader, and we will get the string and display on the string console. So get the string, so use the file reader, get a string. So if you want to read and write, the unit to read and write is a line, not a single characters. We should use a buffer reader and buffer writer in our experiments. So we use a read buffer reader and the buffer writer. Each time read a line, a string from it. So it's the second code, a reader 9. Use a buffer reader, reader 9, and use print out, system out print 9 to print out the string. And the first code, we use the buffer reader. So each time we read a 9 from the keyboard. It's a nano string, a string. So we save it to a data file. Uses buffer writer to write it to a data file. Each time by line. The 11th chapter about applet, I think only one novel is enough. It's not so many contents for this chapter. And then the rest of the time for the next class, we will have one hour. The next class, so we will give you guidance for the final project. I will give you the guidance how to think about this final project, what you should do, what you should think, the structure for the final project, how to make this interface for this application. I will give you some guidance. So next class is very important because it's connected with your final project. I wish all of you are here on time, okay? No absent, because it's very important. Any questions, please leave a message on WeChat box. That's all for today. Thank you all. That's the end of the class. Okay. Thank you. This one I have sent it uploaded to the DIPOP. All these documents in the DIPOP.
That's it. You could resend it, like you could resend it. You could resend it.
Listen everything. What is it? Oh yeah, this all this information and DIPOP. I have already uploaded the DIPOP, so you just download from DIPOP. It's if you use my computer. All the file. Okay.
I think I'm going to late, so I didn't answer your question.
Yeah. Okay, wait.